Hi, hello. Today in this video, we discuss about construction and working of semiconductor laser. First of all, what is the meaning of semiconductor laser? Semiconductor laser is another type of laser, wide variety of application. Efficiency of a laser is very high. Semiconducting laser material having two properties. One is direct band gap semiconductor and second one is indirect band gap semiconductor. First one we discuss direct bandgap semiconductor. The recombination of holes and electrons without change any momentum. They produce energy in the form of heat. And second one is indirect bandgap semiconductor. The recombination of holes and electrons with change in momentum. They produce energy in the form of heat and phonons. Semiconducting laser material having two criteria. First one is direct bandgap semiconductor used active medium. Semiconductor is degenerative semiconductor. P-type and N-type is heavily doped. Is benefited for achieving lasing action. If the both criteria is satisfied, the compound is called gallium arsenide. Gallium arsenide is earliest semiconducting device. So, a normal semiconducting material. Silicon germanium compound semiconductor. The recombination of holes and electrons is energy in the form of heat. And gallium arsenide compound. The recombination of holes and electrons release energy in the form of light or photons. This is all about introduction of semiconductor laser. Construction of semiconductor laser. Gallium arsenide semiconductor falls in the category of homojunction laser. What is the meaning of homojunction laser? This means only one junction separates p-type and n-type semiconductor. Homojunction laser is made only compound is called gallium arsenide. Gallium arsenide compound having two layers, p-type and n-type. The first layer p-type is filled with holes and p-type impurities. And second one is n-type is filled with electrons and n-type impurities. The diode is very small in size. The order is about 1 to 100 micrometer. Top and bottom faces are polished. We see top and bottom two faces are polished. Polished face. One end is partially reflective and other end is highly reflective. Both the ends are roughened. In this diagram shows roughened face. Both the ends are roughened. Avoid any reflection if two metallic contacts. And in this diagram shows polished face, laser output, metal contact, PN junction, roughened face, metal contact, polished face and power supply. and working of semiconductor laser. We apply small forward bias across the junction. Electric field will set up and junction barriers will be broken. The energy band diagram heavily doped PN junction is shown in the diagram. The thermal equilibrium and Fermi level is uniform because highly doping in inside Fermi level pushed into the conduction band. The electrons occupied in this portion. The conduction band present below the Fermi level and p-type Fermi level within the valence band. Holes occupied in this portion. Valence band present above the Fermi level. Holes in p-type and electrons in n-type are pushed into the p-n junction. This result, recombination of holes and electrons takes place. Photon will be released, move in random direction. This is similar spontaneous emission. If we increasing the forward bias, population inversion can be achieved. Initially, concentration of electrons in the energy level at the bottom of the conduction band will less than the energy levels top of valence band, so that the recombination of electrons and holes result only spontaneous emission. The junction works as LED. When current exceeds threshold value, population inversion is achieved active region, which formulated in the junction. Since the energy gap of gallium arsenide 1.4 electron volt, the wavelength of emitted light is 8400 angstrom. This is all about working of semiconductor laser. This is very important question for first year engineer for first term physics cycle. Thank you.